Section B, answer all questions section. Just circle the correct answer, and then there's some more additional information. 7. Which row shows the number of each fundamental particle in 125 mg 2 plus ion? So it should be a 12 here if you look at the periodic table. So the number of protons is obviously going to be 12. So we can eliminate B. Number of neutrons was going to be the top number minus the bottom number, 25 minus 12, which is going to be 13. So now we can eliminate A because that says 12 neutrons is clearly 13. And the number of electrons, because 2 plus ion, minus 2 for the number of electrons, so 12 minus 2, that's the number of protons and electrons. 12 minus 2 is 10. The answer is C. And this multiple choice question shows the fundamentals of A-level chemistry are still very important. You do need to know them. And yes, it's just a mark, but 1 mark can be the difference between a grade B and A and A star, pass or fail. So you do need to know atomic structure as well. 8. What is the relative molecular mass of benzene 1,4-dicarboxylic acid? You work out the MR. Benzene, you know, your C6H6, and then your 1,4-dicarboxylic acids, 2 carboxylic acid, and you should get 166.0. Which substance has significant electron delocalization? So it's going to be graphite. Some specification. In bonding, you need to know the structure of it as well. Which reaction has standard enthalpy change equal to standard enthalpy of formation for barium chloride? It can't be these ions, because standard enthalpy of formation definition is in its standard state, standard elements, not ions. So it can only be A or C, and obviously barium is in gaseous state in this case. Well, it's really not, it's a metal, so it needs to be a solid, so the answer is C. This is a Maxwell-Boltzmann distribution for gaseous reactant. What is represented by total area of the curve? Total energy of particles, no. Activation energy for reaction, no. Total number of reactants. Now these two are where students, including myself, will trip up on. The total area under the curve is the total number of particles. Is it the total number of reacting particles or total number of particles present? It's total number of particles present. That's why they clearly added that to trick students out. 12. The rate of reaction is greater when a catalyst is used without changing the temperature. Which statement explains why the rate of reaction is greater with a catalyst? The collision frequency increases because the catalyzed reaction has a lower activation energy. That sounds correct, so let's not cross it off yet. The collision frequency increases because there's an increase in the average energy of the particles. No. Proportion of successful collision increase because catalyzed reaction has low activation energy. Yes, definitely. Proportion of successful collision increases because there's an increase in average energy. Definitely not. The answer is C. It's not A because the catalyzed reaction does have a low activation, but it's not the collision frequency. It's the idea of the proportion, because the collision frequency is what? Number of collisions, right? But they have to be successful collisions in order for it to be for the rate of reaction to be greater. 13. What is the value of equilibrium constant? Well, we've got our products over reactants, right? So H plus F minus over my reactant HF. I'm given HF, I'm given F minus. And here's the thing we need to do. Well, how do we find out the equilibrium constant? Well, all it's going to be is H plus squared. Because this is equilibrium established, H plus is equal to F minus. So all we're going to do, put in our calculator, is (2.0 times by 10 to the power minus 3 all over 7 squared all over 7.70 times by 10 to the power minus 3. 6.87 times by 10 to the power minus 4. Which oxide is named element its highest oxidation state? I got this wrong the first time I attempted it. I was like, how did I get this wrong? How? Because I didn't read the question properly. It's a very tricky question. In which oxide is a named element in its highest oxidation state? It doesn't want you to find out the oxidation states and then say, okay, that one's the highest. No, in that element, the named element in its highest oxidation state. So let's go through it. Chlorine, ClO2, oxygen -2, -4, so chlorine is going to be +4. So let's just work out oxidation states first. Magnesium oxide +2, nitrogen N2O4 +4, sulfur and SO2 or -2, 10 by 2 is 2. No, -2 times 2 is -4, so therefore sulfur is going to be +4. Now you might be wondering, well, A, C, and D then, because they've all got oxidation state of +4. No, but the question says, is the named element in its highest oxidation state? Chlorine, well, Cl, that's in group 7. So the highest oxidation state for chlorine is +7. So therefore it can't be A. Magnesium is in group 2. So the highest oxidation state for magnesium is actually +2. Nitrogen, group 5. Highest oxidation state is +5, therefore. Remember the group number usually tells us the oxidation states. Sulfur and sulfur dioxide was also in group, and this is actually in group 6, not in group 5. So the highest oxidation state is +6. Is +4 the same as +6? No. Nitrogen, well, it's 1 lower than its highest oxidation state. Magnesium was +2, and it's the same as its highest. It's in its highest oxidation state, which is +2. It's a bit of a tricky question. What happens when water is vaporized? It's definitely going to be this or this. It's A or B. Covalent bonds break between molecules, or the idea of intermolecular forces are overcome. So which one is it? Which one is it? Remember, when water is vaporized, you don't need to overcome the covalent bonds. It's the intermolecular forces that are overcome. 16 species can behave as a Bronsted Lowry acid. So in order for it to behave as that, it loses a H plus, right? So NH3, well, that really wants to accept the H plus to form NH4 plus. So it's not going to be D. BF3, it has no NH pluses. It's BF3. It has no H pluses, so it can't be C. HCO3 minus, well, actually, it must be that because A has no H pluses. So how's it going to lose something it doesn't have? You can't lose bread if you don't have bread. You know, you can't lose something if you don't have it. So it's not A, and therefore the answer must be B, and it makes sense. It's got H, it loses the H plus, and then it forms CO3 2 minus. So the answer is B. Loses the H plus, aka proton donor. But the losing the H plus really makes it understandable when you're doing these kind of 1 markers. Which change causes the pH of that NaOH to be halved at 290 Kelvin? It says that D. Adding 10 centimeters cubed of that much HCl. Because if you add, because obviously Kw is equal to H plus ionic product of water, H plus or H minus. And if we're adding 10 centimeters cubed this much of HCl, so what we're increasing is a H plus concentration. Now if we're increasing the H plus concentration, what does that mean for the pH? Well, the pH equals minus log 10 of H plus. So, well, if we're increasing that, well, then as H plus increases, pH decreases. In this case, pH will be halved at 298 carbon. 18 was the value of Ka for this acid. Well. There's a lot of equations in this case that we could possibly need, but in reality we don't need these I'm writing down right now. I'm just saying this is what my thought process was, maybe this is yours. Ka is equal to 10 to the power minus pKa, pKa is equal to minus log 10 of Ka. In reality we don't need any of those. You should know Ka is equal to H plus A minus over HA. And what we're given of a weak acid. It doesn't tell me weak acid. I can find out the concentration of H plus ions very easily, and therefore I can find out Ka very easily, because H plus is equal to A minus. So it's actually going to be Ka is equal to H plus squared over 0.100. But remember, it's a 1 mark, even if your method is completely wrong. I'm just saying, as long as you get the correct answer, that's what we're trying to show. So pH 2.50, well, H plus is equal to 10 to the power minus pH. H plus, concentration H plus ions is equal to 10 to the power minus 2.50. Once I've got the H plus ions, I've already got that. Substituting here, I should get Ka is 1.00 times by 10 to the power minus 4. These two equations I thought I would need, but you don't need them. So sometimes if you're struggling with this, write down the equations, you like all the possible equations, and then realize actually I can't work out pKa because I'm trying to find out Ka, and I'm not given pKa, so I don't need Ka is equal to 10 to the power minus pKa. I don't need pKa is equal to minus log 10 Ka. 18, which statement is not correct? About a pair of 3 elements, sodium and chlorine. This is just your memorization of the trends, the trends. In this case, you got trends in atomic radius, melting point, and first ionization energy. And the answer is that the rest of them are obviously correct. Sodium has the largest atomic radius, that is correct. Silicon has the highest melting point, yes. Micromolecular structure, strong covalent bonds. Is it? No, it's not. No, it's not got strong covalent bonds. It's just a really big molecule. Yeah, I mistaked it for sulfur, I'm pretty sure. Chlorine has the highest first ionization energy, that's correct. So the statement that is false, I like to really write false. I know it's the same thing, but just sometimes you can get confused in time pressure. So which statement that's false is sodium has the lowest melting point. Equal volumes of pairs of solution mix, which pair forms a buffer solution? Ammonia and ammonium chloride, yes, that will form a buffer solution. 21. Barium metals added to a large excess of water. Which observation is correct and complete? Barium metal to a large excess of water is going to be a colorless solution with effervescence. That's what it's going to be. And this again, this is a A1 question, just testing your knowledge of tests and all of that. Which species is the strongest reducing agent? Now, the strongest reducing agent, I'm looking for the negative ions. And so I can cross out F2 and I2. They're not going to be strong. They're not going to be the strongest reducing agent. So F minus and I minus. Well, I minus is lower down the group than F minus. So I minus is going to be the strongest reducing agent. Which statement about the shapes of ions is not correct? False. A COCl4 2 square planar. That is square planar. Square planar, what is that? Octahedral? No. Square planar is 6 bonding pairs, 2 lone pairs. 6 bonding pairs, 2 lone pairs. Yeah, that's not true. It's not square planar. 24. Which compound can decolorize acidified potassium mangate 6,7 solution? FeSO4, the Fe2+, easily oxidized. Which statement about catalysts using reactions at equilibrium at constant temperature is correct? They are always used in the solid state. They increase the rate of forward reaction but decrease the rate of reverse reaction. That's definitely false. They increase the rate of forward reaction and reverse reaction equally. They have no effect on value of equilibrium constant. Boom. That's true. Only temperature can affect the value of equilibrium constant. Consider this reaction scheme. Which step is shown with the correct region and the correct condition? So step 1, HCN dissolved in water. No. Ethanolic potassium cyanide? No, it's not that. Potassium hydroxide dissolved in warm water. Step 2. Yeah, but then why are we forming a double bond? Why are we forming an alkene? That's not it. CH3OH with an alkaline catalyst. No. H2 in the nickel catalyst. Yes. And what is this called? Hydrogen catalytic hydrogenation. Which process does not involve the heterogeneous catalyst? Catalytic crack of alkanes, contact process, decomposition. Definitely not that. Why would that involve the heterogeneous catalyst? What is the mole fraction of butane in a mixture of butane and oxygen with a minimum amount of oxygen used for complete combustion? So we can't work out moles, mass of M1, all of that. We're going to be working out with the molar ratio. So we've got 1 here and that's 6.5. So we've got the mole fraction of butane. So we've got butane, which is a mole of 1, over 6.5. But that's not the total moles. Mole fraction of butane is moles of butane over the total moles. Well, total moles is 6.5 plus 1. I feel like that's the tricky part, adding that plus 1, realizing this is the total number of moles, and this is obviously the moles of butane. And if you put that in your calculator, 1 over 6.5 plus 1 should get 0.133 occurring. So the answer is A. 29. Which is not a possible product of reaction between potassium hydroxide and this? That is definitely a possible product. That is definitely not. These two, yes, all they've done here is change the one from here to here. That's all they've done. So yeah, you can kind of cancel these two out immediately, because you're like, well, what they've done is rearrange the double bond, right? Move the double bond. And in this case, yeah, no way you're getting the C double bond or function group. 30. Most scientists believe that the concentration of ozone in the upper atmosphere should not be allowed to decrease. Now, what does that mean? Well, the scientists are saying that they don't want it to decrease the amount of ozone. So therefore, they're kind of saying that it's a good thing. They don't want you to decrease it. Because if it was a bad thing, they'd obviously say decrease it. So it's clearly a good thing. So obviously, all of these are going to be advantages. Ozone helps prevent global warming. Prevent global warming, no. Efficient disinfectant, no. Helps remove pollutants, which is chloralkane, no. Removing pollutants, I think that's what, I can't remember it now, but the answer is D. Ozone absorbs harmful, or in this case, ultraviolet radiation. What is the name of compound X? This is literally it's not a test on your mechanism. It is a test on your mechanism, but it's how well do you know your mechanism, and then how can you apply it to this type of question. Well, we're going from a compound, so let's just say question mark, wrapped on it with H2SO4, sulfuric acid, forming an intermediate, and then we're adding excess H2O to form an alcohol. It's this classic one, alkenes will react with cold concentrated sulfuric acid to form alkyl hydrogen sulfates, and that's not it. And then hydrolyzed, so we add water and we warm the reaction mixture. The warming part is not included in here, but it doesn't need to be. Adding water is the main part, and then hydrolyzed to form an alcohol. So what is the starting product? It's an alkene. React with cold concentrated sulfuric acid to form an alkyl hydrogen sulfate, which is an intermediate, and then hydrolyzed to form an alcohol. Excess H2O to form an alcohol. So the name of compound, it must be an alkene. Therefore must be a propene. Aldehyde, no. Methyl benzene, well, definitely not ethanamide, but some students could see, I guess, methyl benzene. Remember, benzene, methyl benzene is not an alkene. And then 32, which is the correct equation for oxidation of 1-phenyl ethanol, and O represents oxygen from an oxidizing agent. It's pretty nice that they included that, but you should know that. Oxidation of 1-phenyl ethanol. So the phenyl, 1-phenyl ethanol. So it's gonna be, it's gonna be between C or D, and the correct one is D. 33. The skeletal form of two compounds are shown. Which method will distinguish between samples of these compounds? Well, what are these both? These are both aldehydes, right? They're both the same. You know, in this case, you've got a methyl group, but they both have the same part. So we can't use Tollens region because we'll get the same result. Same with acidified potassium dichromate solution. And obtaining molecular masses from the high resolution mass spectra. Would that work? No, because they've got the exact same masses, or extremely similar, because all they've done is this methyl group has gone here. Yeah, so it's going to be very similar or the same. So the only method to distinguish between these samples of compounds is comparing the fingerprint regions of the infrared spectra. The fingerprint region is the region, just to clarify, region below 1500 centimeters to power minus 1. Which compound is the strongest base? Well, it's not going to be B, because the benzene ring has electron delocalization, so that's going to definitely affect the base. And it's not going to be NH3 or NH4Cl, it's going to be A, because it doesn't have the ring of electrons, and it has, you know, this cyclic structure with the NH2 and, you know, this alkyl group, so it definitely will be the strongest base out of these compounds. Which statement about enzyme is false? Not correct, false. The tertiary structure of enzyme influences which molecules combine to the active site. That is true, definitely true. The action of enzymes can be inhibited by a molecule or ion that binds to the active site. Yes, inhibitors. Enzymes work equally well on both optical isomers of a substrate. That is false. And D, computers can be used to design drugs to block active sites and enzymes. That is true. That is literally the specifications about computers using to design drugs to block active sites and enzymes. Cisplatin has a formula that cisplatin is an anti-cancer drug that prevents replication of DNA. When cisplatin bonds to DNA, which is the correct ligand replacement reaction? Replacement of one NH3 ligand, replacement of two NH3 ligands, replacement of one NH3 ligand and one Cl- ligand, replacement of two Cl- ligands. The answer is D. Cisplatin, you know, I've seen it come up now in these papers. You need to know the ins and outs of it, the formula for it, you know, the correct form, like how to draw it, how, what it does, how it does it. Transplatin as well, when the Cl minus ligands are opposite each other and all of that. So cisplatin is also an important topic, and because it's not a really long topic, it's just like at the end of what's it called, amino acids and DNA. Those students probably forget about it, but definitely do it. So the answer is replacement of 2 Cr minus ligands. That's the end of multiple choice question.